schedule. So I want to present like a presentation I saw on the ElixirConf EU in Lisbon, and I actually saw it as a lightning talk by Andre Albuquerque. So it was like a 2-minute presentation where he showed a demo um, called "The Doomguy Visits the Beam," and I was so curious after seeing it, like how does it actually work, and how did he get that done? That I wanted to dive into this and share a bit as well with you guys what I learned doing that. So it's not my credit. It's all the credit goes to Andre, who did like the initial work on this and actually committed most of what he did there to GitHub. And I'm just gonna reuse his material and go a bit about what we're doing here. So his idea is that these supervision trees that we know from Elixir and Erlang are pretty complicated to understand. That's really distracting. Who understands supervision trees in Elixir? Oh, this is actually quite a bunch. So there's like one for all, rest for all, for example, and one for one, right? These different strategies. And his idea was, let's try to get this into Doom. So there's something he wrote which is called the Doom supervisor. And when I start this up, this starts an Elixir program, and this launches Doom. And oh, didn't say somebody something about sound here? Like, let me try whether that works. It is plugged in. I can try to plug it out and in again. We will have to do without sound, I guess. And now I can, from here, send commands. So I have this, the supervisor. Actually, I'm realizing I need to ensure I can't be killed by the monsters. I take this line here to start a supervisor. And this starts 5 monsters. Now, I gotta find my monsters. And I had this problem last time as well. Ah, come. Clip off? Ah! No clip. Oh, you're my rescue. So we can walk through walls and try to find out. I should have brought a mouse. Now I see what I did wrong. So when Andrew showed this, he managed to have these monsters appear directly in front of him. And when I tried this a couple of times, they would show up randomly over the map. And we can look into the reasons for that in a second here. So what you can see on the left-hand side here in the Elixir screen is actually that every time there's an event, there's a message that makes it to Elixir, and Elixir becomes aware of what's happening here. So we can just try, let me try this again. Yeah, I want to, that's what I want to spawn monsters again. So we get 5 here, but I want to see whether I can get lucky and they spawn nearer to me, which would be really, really great. Oh, this is also amazing. Now I will win. And I can fly now. If anyone can spot 5 running demons, then we will be in the game.
They might not show while you're outside the...
You think so? They will not show up when I'm...
Some games, the characters
they clip them out.
no,
don't do that. They should though. This is, I think, the... Oh, I saw something. No, I can't reach them. Why don't you add like... There are they! But I can't get to them, huh? No, go ahead. What was the suggestion here? Launch more! This is... I like that suggestion. Let's try that. Gonna stop them. and our monsters die. Let's try, I don't know, 50? And we usually see like the position they're being spawned at. I'm not sure what my position is. X. So there's more. There's definitely more now. I can see some dead bodies back there, I think. Mm.
Looks like they're behind the mountains.
You think that? I love this. I love this. I can give it one more try here to show this, and then you will see.
They're all at the same Y coordinate, which is weird.
Maybe it's an anti-cheat mechanic.
I'm sure that's what it is. So I'm starting the game again. Just popped it up one more time. And do no clip and God. And go ahead. 50 more. X, Y. That must be Y, right?
But they're all dead yet already. Who died?
They died.
Ah, yeah, they died instantly. They're just dying.
They just die? Then they must be outside if they're dying, huh? Let's jump to the code and go to the presentation. Maybe we can fix it in this during this talk. And we can talk about what's happening here and how this communication actually works. So we'll have to figure out how he got the position right. This is the supervision tree. We didn't show it, so we're going to come back to that once they pop up in front of us. But basically it shows we can kill one, they come back. We can kill the first one in restfall, and then the others die, and you can really visually see it. So let's jump to that when that works. There is like communication between the Doom game, Elixir, and a plugin to Doom. So this is using something called GZ Doom, which is an open source Doom port that Andre found. And that open source port also has a scripting language. So he first tried, and there's some code of that in his GitHub repo, to actually have Elixir talk the full net event protocol. So that's a protocol that Doom is using to talk between each other to the other clients. I don't know if this is actually good size, right? I think this is visible. So there's like a bit of quite a bit of comments here about how that protocol works and how it's being compressed. But then eventually that always disconnected, and he tried a different approach. He added into Doom, so he changed GZ Doom and added some more C code into it to open an UDP port inside Doom that you can use to send from Elixir commands to that, which is really great. The problem is I checked out this game server, and then I checked out GZ Doom from his side. He forgot to push the commits. So there's actually, when you start this up, just with what I tried initially, just with a normal GZ Doom, nothing. There's no connection, and Elixir actually can't talk to it. So instead, I had to go in, looking at these slides, trying to figure out what he did, and then re-implemented that until basically before this presentation here to get this going. This time, though, I will commit it to Git, and you can try out. So there's certain commands that are being triggered from Elixir and being sent to this UDP protocol into Doom. So and I can show that basically when we do one of these commands here in the game server. Or like actually, let's take a spawn of 1. So I'm just going to restart this. And this is so dark here. Let's get to some bright areas. Where's the bright area? Here's the bright area. And copy paste
this. And then we see that there's a spawn monster command that is make. Oh, no, there he is. There he is. So this happened to me before. So for some reason, these monsters, the position calculation works correct, and he died. But on the supervision, it doesn't work right. So there must be some simple code change. Actually, there's also like a position here, right? So that's maybe we can just hard code that in a second here, somewhere, to get the supervision work. I cannot copy paste. Cool. So we see the message, and we see like this spawn zombie man ID 123 not used. So this is a command we actually sent to UDP to Doom. And then on the other side, so this is the source code of Doom. There is now I added this function. I guess this is exactly the same thing that he did. So there's an inet CPP file. He mentioned that in one of his source commits, like where he said like that there's a problem in this file. And there's an Elixir packet get that listens on one specific port and always tries to get just one UDP packet. And whatever that UDP packet is, we take that in here, like the whole thing, put that into a buffer, and then turn that into what DoomNet calls a net event. Then this net event is being broadcast to everyone who's in Doom. And then comes our third participant in the soul. There's also a script. So if I want to jump forward to this slide. So we have Elixir that sends a UDP message to the Z script, just in the way we have just seen it. And then that Z script controls the game. And the game then prints messages out where it says, there is a new monster spawned, or somebody died. And these messages are read back by Elixir. And then it reacts. And so the supervisor knows, oh, this monster died. I have to respawn the monster. Sends another UDP message, goes to the Z script, goes to the game, goes back again. And the Z script was really fascinating to me as well to learn about that. So Andre did add that. So there is an event handler. So this is a programming language made and invented only for GZ Doom. And it actually has a JIT that it compiles down to assembly. It looks, I don't know, a bit like Java-ish. So it has classes and overrides and types. And so it gets these console events, which is actually, when I received the UDP packet, I turned that into what Doom calls a net event. And then this is what this network process gets. It gets exactly this raw string here. And then that splits it out. Based on the colon, we saw this spawn monster, and then there was like an ID. And out of that generates a random position for that monster. So I think somewhere here is like our positioning issue. And then actually spawns that monster. And so this code, I guess, is where we probably have to find what the issue is with the position. I can do that. This is actually what I used to reverse engineer, like this slide, what he's doing. So there's this game server, does this start game. Who knows what an Elixir is a port, or port communication? Yeah. So that's the idea. Yeah, there's two hands here. But this is 3, 4. Okay, it's rising. It's like an auction. Who offers 5? This is when you open a C program or like any other program outside of Elixir, but you actually use standard in and standard out to communicate with it. And this is what's happening here in this game starter. So there's actually a call, and that opens with using port open an executable, which is the game binary path, which is gzdoom, or gzdoom based on the environment variable, because I changed this code a bit. It was hard coded to Andre's home directory and his build of gzdoom. So instead, now it's I put an environment variable there. I could also have hard coded it to my home directory, I guess. So it gets that game binary path and then launches this binary, And when that launches, it's actually using Erlang process communication. So every time when there's a line produced by the game, that sends a message to Erlang. And in the same way, Erlang can send back messages. Actually, when I opened this and I saw that I'm missing the source code for GZDoom, I was thinking, well, I don't need this UDP port. I can just send back to standard in, and it will take these commands. Until I realized that the developers from GZDoom, they focus mostly on Windows. On Windows, the standard in for controls is not really a thing. So GZDoom never reads standard in. Whatever you send there, or like, you cannot control anything. Nothing happens there. And so you have to open another door to get access to the console. And I can show that real quick. So what is happening, the game server is using the game starter to start up the port. And then this is just the gen server that has a handle info. And it receives basically from the game line by line data. There's a port that's like the program running externally, and this means there's an end of line. So this is the line it received. Now there's this interesting prefix here because we have two variants. One is a normal line that is not for Elixir, is not from our small program. And we see them down here, like received net event or tagged new zombie as ID. And then there's some that have a prefix, and there's star, star, star. So this is what actually the program internally is using for controls. And this little prefix here is Elixir star, 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 Elixir star, star. And because this is coming out of these Z script that we talked before, it does produce the star, star, Elixir. So every time there's a push Elixir message, we get this prefix that's going to standard out, and then Elixir is doing this filtering, seeing the prefix, this message for me, reacting to it. There we go. This is a bit of like how the supervision actually works, because there's one part of just the communication that I personally was most interested. The other part is how does the supervision actually reflect itself into Elixir. And so there's a registry that's actually keeping all the monsters and the ID association to these processes. So when we saw here this monster ID, did we see it? ID 123. Then this is being used to connect that to the pit on the other side. So there's a registry that connects it. Basically, if this monster dies, that's called 123, then it means in our supervision tree, this pit should die. And in the same way also be restarted. This is this. There's more demo time, so I want to jump back and see whether we can get the position right for this. And let's get into that for 1 second. And if somebody has a good tip, it's easier. So my idea here was, there is this position from Elixir. My idea was actually just to hard code some of the positions that we just got here. So I hope I did note them down here. Yeah, so we got this because that was really near to where we are. And then we have this random position around. Yeah, I was just about to do that, and then I thought maybe that is a bad idea, but I don't. So I wanna keep this. I'm gonna comment these 3 lines, and then maybe XYZ I can just use these numbers. Let's see. So we have 2088. We got. I don't know what language that is. Like GZDoom script, Z script. I think that's what the Z script. Yeah. I don't know how. I'm actually pretty amazed about this find that there's like another JIT compiled language. I mean, imagine how many years did it take Elixir to get JIT compiled, and they just said, yeah, for Doom obviously we need it, so we just do it. Did I do this wrong? What did I do wrong here? Oh, I see. Thank you. Good catch. Okay, let's see. Let's see whether this did. There's a mouse. I want to get back to the open space because if the positions are every time the same, it should be here now. Huh?
Well, it depends on the range value, but hopefully that's not too big.
Yeah, I hope that's enough so they're just not on each other. That was kind of the idea. Let's see. If they even go through that function, I think. Ooh. Die to shut down. Look at this.
But the monsters didn't die.
I think there's too many. No? What do you guys think? This looks like connection issue. Oh, yeah, we're just at the right spot. Just restarting it. And one more time. Did you see anything? Oh, you know what I did wrong? What I was just talking about. I was running it with a normal stock GZ Doom. So I have to give it this environment variable to my home directory to know it uses my build of GZ Doom. Yeah, no, that's not what I wanted to do, but it looks good. One more time.
You started in paranoid
No, it's still at -199.
Yeah. So that was not the right. Stop it. That was not the right function. I really like that. So I think the problem is it's not going through that function.
There's one below it that said take the position from Elixir. Yeah, the function below.
Yeah, right? This one here. Maybe that's wrong. To return. Should be fine. Oh no, the random probably not. I don't know what this is for here.
Do you need to compile it or anything?
No, so the Z scripts, they don't need to be compiled. They're just being read just in time and then just in time compiled, I guess. So that should be fine. And it's shooting again. Oh, this looks better, no? It looks now they're all in the same position though. So let's, yeah, let's, the random was right, huh? Oh, I feel we're really near to this.
But the random is just
Space in the other function.
space them out. 74.
Tell again, what should I do? Tell me again. F.
This is random from here and just uncomment previous function. I think it's
The previous function isn't called.
I should define a range. Is that what you're saying?
Yes.
Maybe 50 and that.
Is that integer range? Oh, how do you do that here? Let. Maybe I can use let. I saw that. Well, it says no. It says let here. Like I don't know what. Let's see. Yeah. Okay.
You force them to be in the swimming pool.
Where am I? Where's the pool? Yeah. Who knows Doom really well? Like, you guys should know these levels in and out. Oh. They're very near to each other. Amazing. Let's see whether this works. So we can I kill one? I don't know how many. I think this is good. Yeah, so he dies and he comes back. Let's try this again. Is this working? Exactly. So we have the strategy we have right now started. The supervision. I think the distance between them should be a little bit bigger. Right? And the supervision we have started here is 1 for 1. So 1 for all is pretty interesting. I want to have a look at this. Let's shut this down. Yeah, they all die. Let's get this window visible here. What did I do? And get 1 for all going. Okay, here they are. And then they all die, and they're all being recreated by the supervisor. And the last one is if you do rest for all. Gotta kill the supervisor, restart it.
You're really making a mess.
Yeah, that's true. That's true. Let's see whether we can use a bigger weapon to get them all done. And then they all die. And we have a crash. We have a crash. Sand event. There was probably too many killed in game. Well, did it say what happened? Is it shut down because of too many restarts? Cool. So I think this is this. I'm actually interested in trying to space it out a little bit more. But you guys don't have to watch for that. So that was I really liked that presentation from Andre Albuquerque. I will push the commits and the changes. There still must be a bug because I think actually it tries to get the player position in that flow from Erlang to from Elixir to the game to ZScript. There's somewhere where it's trying to pass along the position, and that's kind of the code we just hacked and like hard-coded one position in the open field. I'm a bit curious of finding that bug. Maybe I introduced it when I fixed it, which is usually the case when I try to fix something, and then go from there. Do you guys have any questions? I have a question. Why did the sound not work?
We don't know.
It's okay. Just kidding.
We probably forgot to put in a semicolon or something like this.
Cool. And thank you so much, guys. And we can talk. Don't ask about like the productivity value of this. Like I don't think there's any of that. But you can spawn monsters now from Elixir. That's pretty cool. So.
Administration tool.
Yeah, exactly. Shut down your processes. There's like there's a PS Doom. I looked into that a bit. I don't know if you ever seen that. It's like a kind of similar idea for sysadmins to kill their processes in Doom. But it seems to be actually like it's all in C. So it's not like a plugin into an existing system, but it actually they did some modifications in the game, so you can actually in Doom see your process tree, and then go hunt them down. I don't know if they like. I guess the process should be bigger when they consume more memory or something, so that the sysadmin, get after the big monsters first. So definitely some of these ideas haven't been there before. But if you want to learn about how your supervision tree will behave, that's a nice visualization. Like one visualization that I really like that we didn't get to is when we do the rest for all, that you can get into an unstable state for quite some time. And Andre was actually showing that. So if I spawn these up here, and if I'm able to find the spot again. No, that's the other side. Look at this. Now they're spread out further. Let's see whether this crashes again. Oh, this worked pretty nice actually. I think they all came back. Let's see. Yeah, now we see like this kind of instability that some of them die again because it tries to get them up in the right order. And supervisor. Why? I think it's down. The system is down. We killed it properly with the BFG. Cool. Now I finish it. We saw the instability at least once, so I'm pretty happy. Thank you for that. And thank you for the mouse.
I mean, I also saw this lightning talk. When did he do it? It's just recently, right?
Yeah, just on the Elixir Conf in 18th of April, I think.
Ah, yeah, sure. The lightning talks.
Yeah.
And I wonder, isn't there any kind of real 3D real-time visualization available? I mean, that would be really cool. I mean, that's probably a way to make an excuse to buy this new Vision Pro camera from Apple. Imagine you could just permanently watch your code running in a 3D visualization where you can really look around and all your processes are just cats lying around.
I mean, there's quite a bit actually. I'm always pretty amazed by the observer.
Yeah, but it's 2D. Or
it's 2D.
Or is there any dimension I haven't yet discovered? Yeah, but doing this in 3D with all the benefits of real-time rendering, color, position, anything. I mean, would be a good idea, I think, to just visualize Elixir programs, because it really gets complicated once you have lots of processes lying around, especially as there are usually like hundreds more than you actually think of, which are just randomly created by the frameworks, just in case. So I think it's just an interesting idea how to visualize running code in a way. But I haven't really seen any other idea or experiment or prototype doing that yet.
Yeah, that's a good question. I don't know whether the third dimension really adds value there, but in general, I fully agree that the visualization of like processes is something that could be much improved. And actually, when you debug a system, an Elixir system, that's something that often is right now still difficult. So for example, if you have a web server and it's getting tons of requests and you want to know which one of them are slow and where do they go along, like there's some of these tools like the observer, but the observer really falls flat. Like you can look at which processes are using most CPU for. Oh, I'm not sharing any. I thought I'm sharing anything. Yeah. So I was showing just like here you can actually see like the whole tree of all the processes existing. Usually the ton here is Cowboy, like some web server having tons of workers. And you can also look at your processes, who's doing most of the work. So right now it's this UI that I'm showing you, the WXE server. But if you have a HTTP server, what happens usually is that you have tons of these requests and they're coming in so quickly, like under a second, that they don't show up here. And so they're triggering the most busy function, but you never see them here. So I think there's a lot of visualization improvements that could be done to really help you find the bottleneck or like the pain points in your programs.
You also have to be careful to not to actually slow down your system. we have plenty of different tools that do all of these things. Like, and there's also a lot of out there like who do this profiling, but you have to be very specific of what you want to know. And there's things that look out for slow processes. Like the Beam offers all of these things for you. But there is no like just plug in and it has it all for you just because it's a lot of data and it's hard to do. But yeah, it is possible, but hard on like heavy load production systems.
Yeah, sounds like a fun hack program. So if anyone is curious and has tons of free time, it's like you can also present it then next time.
It's definitely a hole that still can be plugged, but there is interesting projects out there like that go in these directions.
Yeah, I'm definitely curious. We can talk afterwards, but I'm definitely curious about that monitoring and production. Cool. Any other questions? Then thank you so much. And let's mingle a bit more. And then this is the end of the official part. Thanks.